Students who are in Algebra 1 are covering what for most schools will be the last chapter of Algebra 1, which covers quadratic functions. A quadratic function is a polynomial that has exponent 2. Here in our example, we have y is equal to x squared plus 4x plus 7, and we want to graph it. We are going to graph it using two methods. The first method is using the standard form. When you graph it from standard form, you will first need to identify what the axis of symmetry is. Once we identify the axis of symmetry, we can find the vertex. And basically, we will be making a table to get the points in order to graph it. The axis of symmetry can be found using the formula minus b all over 2 times a. What do we get b and a? B and a are the coefficients that we get from the equation, which is in standard form. So standard form is ax squared plus bx plus c. So a, b, and c come from the equation. A and b are the coefficients on x squared and x, and c is the constant. And so for this problem, what I tell students is you first need to identify what a and b are. So a is equal to 1, because even though we don't see a number there, we know there's a 1. The 1 is sort of invisible. We don't write 1. It's understood to be 1. And the b is equal to 4. We take those numbers and plug it into this equation. Minus, the minus is already in the equation, so minus b, b is 4, all over 2 times 1. That gives us negative 4 divided by 2, which will be negative 2. This is the x value of the vertex. It is also the axis of symmetry. So if I go to my graph, I will go to x is equal to negative 2 and I'm going to draw a dotted vertical line, because this will be the axis of symmetry. The axis of symmetry is the line that cuts the graph into two symmetrical parts. The next thing we will do is, once we know what the x value is, we take the x value and we plug it back into the equation in order to find the y value. And once we have x and y, that will be the vertex or the turning point of the equation. So our equation is, we have x, so it will be negative 2 squared. Make sure you put all of that in parentheses, plus 4 times negative 2 plus 7. This will give us the y value. Negative 2 squared, 4, plus negative 8, plus 7. 4 plus negative 8 is negative 4. Negative 4 plus 7 is equal to 3. So we have identified the axis of symmetry will be at x is equal to negative 2, and the vertex is at negative 2, comma 3. So I will go to my graph and I will put a point at negative 2, comma 3. 1, 2, 3. Okay, that's the turning point of the graph. Let's look at some important information. The next question says, is this point a maximum or a minimum? Well, in order to determine that without graphing, without using a calculator, we can determine it by looking at the a of the equation. We see that the a is positive, so that means that our parabola, which is what we call this graph, will open upwards, which means it has a minimum. Okay, the minimum would mean the vertex is the lowest value of this graph. And you don't even have to graph it. You can tell that just by looking at the equation. If this one is positive, which we see it has no negative sign, then it's a minimum. If it was negative, then it would have been a maximum. Okay, the last thing, or second to last thing, is the Y-intercept. In order to graph a parabola, you have to have at least 3 points, and there's several ways to get those 3 points. I find that it's easiest to find the vertex, find the Y-intercept, and then use symmetry to find the third point. So the Y-intercept is the point where x is equal to 0. And so you can plug in 0 in the equation, and we find that the Y-intercept will be at 7. So when x is equal to 7, when x is equal to 0, y will be 7. The more you do this, the shortcut is you can automatically see it will always be the Y-intercept, if it's in standard form, will always be the constant. Okay, so we have our Y-intercept. So let's put that on our graph. 0, 7. Okay, so that's our second point. And now we can use symmetry in order to get the third point. What does that mean? Because the parabola is symmetrical, this point will have a mirror image on the exact opposite side of the axis of symmetry. So I count over to the axis of symmetry, 1, 2, and then I go in the exact opposite direction, 1, 2, and there will be a point that will be there, okay, in order to graph it. Now, if you want, you could continue on to get other points, but the minimum you need to graph a parabola is 3 points. And then we can connect it. Now, it's a little bit tricky. You have to round it off, but it looks something like that. Okay, it should be a little bit rounder here. And that's the graph of our parabola.